Let's start with this beautiful topic, computational fluid dynamics. In this video, we'll get insights of three major processes of computational fluid dynamics. It will be brief just to catch up the things for a good start. CFD is for solving fluid flow problems. It involves three major processes as discussed earlier, and these processes are preprocessor, solver, and postprocessor. In preprocessor, we create geometries. We then generate mesh from the created geometry, and we set up the boundary conditions. In solver, we solve the fluid flow equations, and in postprocessor, we visualize the results that we obtain after solving. Now let's have some brief insights of these processes. While pre-processing, we create the fluid domain from the geometry. A fluid domain is volume of fluid that we need for study. As you can see in the image, the water flowing through a pipe. Now forget the pipe and imagine only the volume of water. That volume of water will be fluid domain, which we will need for the study. After we obtain the fluid domain, we divide that domain into a number of small grids or meshes, and it is done for enabling numerical solutions of fluid flow with high accuracy. With this division, the fluid flow can be studied in a very detailed way so that we can obtain high accuracy. Then we'll have input of boundary conditions necessary for solving fluid flow equations. Boundary conditions may be mass flow inlet, pressure outlet, pressure inlet, pressure outlet, and many other such properties. We will be seeing the boundary conditions input later. Now the next part is solver. What it does is solving the equations of fluid flow. The equations are generated through boundary conditions which we give as input. In Ansys, CFX or Fluent are our solvers. The approach which we use in these solvers is finite volume method. Let's not go deep into it. It is just for your information. Now let's discuss a few things about equations in solver. Uh, the simple thing we should know is that the governing equations of fluid flow which the solver solves are generated through three conservation laws. The laws are conservation of mass of fluid, which is mass at inlet is equal to mass at outlet. The next law is momentum conservation or Newton's second law. It says that force is equal to the rate of change of momentum. And the last one is energy conservation or first law of thermodynamics, which says that the rate of change of energy is equal to the sum of rate of heat addition to the fluid and rate of work done on the fluid. Now the integration of governing equations take place in solver. After that, the integral equations are converted to algebraic equations through discretization in solver itself. And finally, these algebraic equations are solved in number of iterations to get the best possible result of fluid flow. The number of iterations can be observed while we see the solver interface in Ansys. The last one is post-processing. It's for visualization of results obtained. Results can be observed through graphs, contours, vector plots, streamlines, and many more. Also, an overall project report can be generated. We'll also have calculators embedded in results to see different properties like pressure, velocity, force at different locations. Also, animated view of flows can be seen. Now let's see these three phases of CFD in Ansys interface. As soon as you open the Ansys workbench under the component system, you can see mesh. Click it and drag and drop it. Similarly, you can click CFX and drag and drop it. It will cover all the three processes that we discussed earlier. On a pre-processing, we will have geometry creation. Then we will generate mesh from that created geometry. Then we will input the boundary conditions in setup. So these three processes belong to the pre-processing. Likewise, the solving will be done in this solution, and the results can be obtained in this section, which can be called post-processing. Later, while we'll be doing the analysis, we'll be connecting this mesh with the setup, and we will carry on our project in this sequential way. With this video, we'll have a small series of videos to see examples of CFD in Ansys. We'll individually be seeing these processes in Ansys interface. So continue with the playlist.